P is a variable point 2t comma t squared on the parabola x squared equals 4ay, whose vertex is at the origin and focus is S. Part I. The normal at P meets the axis of the parabola in A. Find the locus of the midpoint M of PA as P varies on the curve. Part 2. The line from S perpendicular to the tangent at P meets it at N. Find the locus of N. Okay, first part. Get this working. Okay. So, the normal at P meets the axis of the parabola in A. So we need to work out the equation of the normal. So we have x squared equals 4ay, which means that y equals x squared on 4. So if I differentiate dy on dx, that gives me 2x on 4, which is x on 2. Okay, why did I differentiate? Because I want to find the gradient of the tangent, which will then give me the gradient of the normal. So, at the point P, with coordinates 2t comma t squared, the gradient of the tangent, which is the value of the first derivative, gives me 2t divided by 2, which is t. So therefore, the gradient of the normal is going to be the negative reciprocal of that. So negative 1 divided by t, because of course they are at right angles. Okay, so I have that. I have a point, which is 2t comma t squared. So therefore, I can use my point gradient formula to find the equation of the normal. So minus t squared equals the gradient multiplied by x minus x1, which is 2t. Multiplying everything by t gives me ty minus t cubed, and then distributing this negative 1 through is negative x plus 2t. Bringing the x over would be x plus ty. Bringing the t cubed over would be t cubed plus 2t. Good. Now it says that the normal meets the axis of the parabola in A. So let's get a really rough diagram. Something that will look like this. Very rough. Okay, so here's a point P. There's the normal, and if that's the normal, then clearly this is the tangent. This is the point A. That's the point P. And my midpoint would be somewhere here, M. Now, first I'm finding A. So what do I know about A? Well, if it's on the y-axis, then that means that its x-coordinate is always going to be 0. So at A, x is 0, and so I sub that back into the equation for the normal, and I get the following. I get ty equals t cubed plus 2t, or y equals t squared plus 2. And so therefore, A has the coordinates 0, comma t squared plus 2. Okay, now it said that M was the midpoint of PA. M is the midpoint of here. I have the coordinates of P and the coordinates of A, so the coordinates of M should be easy. It's just the midpoint formula. It's the average of the x coordinates, and for P is 2t, and the average of the y coordinates. So it's t squared plus 2 plus t squared divided by 2. Okay, so that's going to be 2t divided by t. That's simply t. This will be 2t squared plus 2 divided by 2. And so if I took out a factor of 2 and divided by 2, that gives me t squared plus 1. So therefore, the coordinates of M are t comma t squared plus 1. Or in other words, I could say that the x-coordinate is t and the y-coordinate is t squared plus 1. And now, I need to find the locus of the point M as P varies. So P varies by changing the parameter t, so I need to eliminate the variable or the parameter t. So to do that, I simply, in this case, I will just substitute, because I have x equals to t, I will substitute into this one, and I'll get y equals x squared plus 1. And that is the equation of our locus. So M, as I vary P around here, M will trace out another parabola, which will be x squared plus 1, and it will look something like this. So this is the point 1, which in fact is our focus for this parabola. So it'll be looking something like that. I have another parabola. Okay, now the next part. the line from S perpendicular to the tangent at P, so this is S, which is my focus, and I know that this coordinate of S is 0, 1. Why do I know that? Because I know for the parabola x squared equals 4ay, it's 0, a. My parabola is x squared equals 4y, so that means a is equal to 1, and so the coordinates are 0, 1. So the line from S perpendicular to the tangent at P, so this is the line that's perpendicular to the tangent, meets it at N. So this point here is N. And remember, this is just a really rough diagram, but that's all we'll need for the question. Find the locus of N. So I need to find the coordinates of N in order to find the locus of N. Now, what is N? N is the point in which the tangent meets this line here. So I need to find the equation of this tangent and this line, the equation of these two lines, solve them simultaneously to find the coordinates of N, and then I can work out my locus. So it's very easy for us to work out the equation of the tangent. I already have the gradient of the tangent. It's t, because that's the value of the derivative at the point P. So the equation of the tangent at P is given by y minus y1, which is t squared, equals the gradient, which is t, x minus 2t. And then that will give me y equals tx minus t squared. Because I'll have negative 2t squared here, I'll bring this over and it'll become positive. So I'll have minus 2t squared plus t squared, and that's where I get this negative 1t squared. So that's my equation of the tangent. Now what about this point, this line Sn? Well, I know that this is perpendicular to the tangent, so it's going to be parallel to this line. You can see that these two lines will be parallel. So if they're parallel, they have the same gradient. And if they have the same gradient, then the gradient of this line should be negative 1 on t. So I have the gradient. I also have the equation of the point S, which is 0, 1. So again, I can use my point gradient formula. Equation of Sn is y minus t squared. Sorry, not t squared. Here I have a different point. My point is 0, 1. So y minus 1 equals negative 1 on t, x minus 0. So that'll be, multiplying by t, I'll have ty minus t equals negative x. Now I can bring the x over here. I'll have x plus ty. Bringing that t over here will give me t. So this is equation 1, this is equation 2, and now we need to solve them simultaneously. Okay, so I will substitute 1 into 2. So substituting this into here, I'll have x plus t times y, and y is t squared, or sorry, tx minus t squared, equals t. Let's move this away now. Equals t. Okay, let's solve now for x. So I'll have x plus t squared x minus t cubed equals t. Factor out an x between these two terms. I'll have 1 plus t squared. Bringing this t cubed over will give me t plus t cubed. I can factor out a 1 plus t squared here. And that's leaving me with this expression. Now I can cancel the 1 plus t squared with the 1 plus t squared here, and I'll have x equals t. So x equals t. Now I need to substitute that back in to find my value of y. So let me sub that back into 1. So when x equals t, y equals, subbing back into here, t multiplied by t minus t squared. So that's going to be t squared minus t squared, which is 0. So I have x equals to t and y equals to 0. That's slanted. X equals to t, y equals to 0. Now, this value for y is unaffected by the parameter t. So as much as I change t, or in other words, change the x value, I'm always going to be staying with y equals 0. And what's that? That means that I'm traveling let's get a different color. I'm traveling here. I'm always at y equals 0, so I'm always on the x-axis. So, therefore I can say the locus of n is y equals 0, that is the x-axis. And that is the final answer.